All right, so let's move on to some other kind of questions. So this one, we're looking at a graph that's already given, and it's basically we're coming down and it's going like that. This one's going like this. And it says describe the end behavior and determine the possible degree of the function. All right. Well, with this one, what is the end behavior? Well, you know, as x goes to negative infinity, f of x goes to negative infinity, and as x goes to positive infinity, f of x goes to negative infinity as well. Okay. Now this one, well, let's do this and then we'll do the degree next. Well, this one, as x goes to negative infinity, f of x goes to, well, it's going to positive infinity. And as x goes to positive infinity, f of x goes to negative infinity because it's going down. All right. Now, what do we know about this one? Well, this one, if we think about it, it's n is equal to even and k is less than 0. So, a possible degree of the function. Well, it's pretty flattened out here, so it's probably greater than 2. But I would say I would just put it this way, minimum degree equals 2. Now, is it going to be probably 2? No, I'd say it's probably going to be more like 6 or maybe even 8. But the minimum degree, so that's a possible degree, is going to be 2 because we know it's even. And then we also know it's going down. And so that's k is less than 0. Well, this one, what is it? Well, this one, if we thought about a real function, it would be going like this. And so we know n is going to be odd. And because it's going the other way than the actual function, k is going to be less than 0 here as well. And so here, what's our minimum? Minimum degree. Well, here it's an odd function, so the minimum degree has to be 3. Okay. Now it could be probably is going to be no, maybe a 7 or a 9 or something like that being so flattened out. But we know it's going to be some degree that's odd, and so the lowest odd degree is 3. And so that's what we'll call this one for the minimum degree. All right, so here what we want to do is we're seeing the local behavior of polynomial functions. So this includes turning points where it goes from decreasing to increasing or vice versa, and our x and y intercepts. So for the first one, what we want to do is determine the x and y intercepts by factoring and by the calculator. So by the calculator, this is what we're going to do to figure that out. And we'll get that after we actually solve this one by doing the factoring first. So can we factor anything out of here? Well, if we look, it looks like a 2 we can factor out. And each one has an x we can factor out. So if we factor out a 2x out of here, that leaves x squared. If we factor 2 out of there, that's going to be a minus 3. If we factor out an x, that's going to be an x. And if we factor out a 2, that's going to give us a minus 10. And if we factor out an x, that leaves that. Okay. So that's 2x times. Now, hopefully, since they said we have to factor it, this is factorable. And so we have x and a plus and a minus. And I can go that far without even doing anything because I know I have to have a negative here. And to get a negative here, I have to have a plus and minus. So 2 factors of 10 that when we subtract them give us 3. Well, 5 and 2 give us 10. 5 minus 2 is 3. So which one's bigger is the negative one. So 5 has to be negative and the 2 has to be positive. Okay. So if we FOIL that back out, that's x squared minus 5x plus 2x. That's going to be minus 3x minus 10. All right. So now what we can do is we can set each factor equal to 0. And so we get here 2x equals 0. We get x plus 2 equals 0, and x minus 5 equals 0. So here x is equal to 0, x equals negative 2, and x equals 5. Okay. And what we've done is we've put y equals to 0 here because when we do that, that's going to give us each of the intercepts. Okay. So what does that give us for an intercept? Well, 0, 0. Then we have a negative 2, 0. And we have a positive 5, 0. So those are intercepts. All right, so can we get that with the calculator? Well, what we have to do is we have to plug that into our calculator and see where those are crossing the axis. So for time's sake, I went ahead and plugged that in. And so it's just, I wrote it down as it was, and our graph looks something like that. So how do we find it? Well, what we need are those zeros there. So probably if we would change our window, that would help a little bit. And so this is, I don't know where that is, but let's narrow it down. Maybe -5 to a 5 and go by 1. Does that help us any? Yeah, that helps a little bit. We need a larger window. Let's go maybe -8 and 8. There we go. Now we've got all the times it crosses. All right, so this looks like it's an intercept. This is an intercept, both x and y, and this is another x-intercept. So what we have to do is we have to hit second, and then we see this calc up here, so we hit second trace, and we want a 0, and so we go down to 2 and hit enter. Now it's saying, what is your left bound? Well, if we're going to do this left one here first, our left bound, we have to go on the left side of where that crosses. So our left bound would be here. And if you notice, it's a negative. So we'll go ahead and say enter. Now we go over. Now we need it to be a positive to be on the right side of it because it's going to cross from negative to positive when it hits that 0. So we'll say that's good. And here we can back up 1 if we want to, or we can just hit enter. And -2, it says, is that intercept. Well, if we remember, that was one of our intercepts we found too by factoring. Well, let's find the others and see what we get. Let's type 2. And now we'll go over here and let's find that middle one. It's probably 0, 0, but you know, we're going to play dumb and we don't know what it is. And so we hit enter, and guess what? It is 0, 0. And then we'll go and calc again. We want number 2. Now we'll go all the way over here. Now we want our left bound somewhere here. Again, we want it to be negative. And so that means our other one has to be somewhere in the positives where that is. And we click, and 5, 0 is our other intercept. Okay. So going back over here, we found all of those using this here. So to get the y-intercept, in this one, we didn't have to do that because we figured out what it is. But the y-intercept is going to be, in this case, the 0. But otherwise, we'd have to do a value. And we'll do that on a different one where we actually have to come up with different intercepts. So we'll save that one for later because this one was our x and our y-intercept. So maybe we should say x and y-intercept, and these two are x-intercepts. Okay. All right, what about the next problem? Okay, well, we have to factor again. And so if we factor, it looks like they all have a 2 in it. And I don't like that negative out in front. So I'm going to factor out a -2. If I take out a -2 here, I have 6n squared plus, now I have just an n. And then here I have a -1. Okay, so it's a -2 times. Now I have to think about what factors here. So I know I'm just having a 1 and a 1, and one's going to be plus and one's going to be minus because, that's how that works. So what I'm factoring this time is the first part. Well, what two factors of 6, when you subtract them, give us a 1? Well, 2 times 3 is 6, and 3 minus 2 is 1. So those are going to be my factors, and I'll have an n and an n, and my larger one has to be positive. So I need a 3 and a 2. Okay, so if I multiply that back out, that's 6n squared. Then I have 2n minus 3n. Oops, I put these in the wrong order. See, so this is why you really want to go ahead and make this so you can check. So that's a plus because I want this part to be plus, that part to be minus. So that's 3n minus 2n is positive n, and then we have -1. Now that's equal to 0. And what we're going to do is we're going to set each of the factors equal to 0. Well, we need to get rid of that -2 out front. So what I'm going to do is divide by -2, and 0 divided by -2 is still 0. And so then I really have 0 equals 2n plus 1. times 3n minus 1. And so set each of those equal to 0. I get n equals, well, this is going to be a negative 1/2. And here n equals a positive 1/3. And so my intercepts are going to be a negative 1/2 comma 0 and 1/3 comma 0. Okay. Now, the other thing we could find is, so these are my x-intercepts. Well, how do we find the y-intercept? Well, we plug in x equals 0. So 0, if I plug in x equals 0 in my original thing, then I'll have 0 squared is 0 times that's 0. So that goes away, and I'm left with 2. And so my y-intercept is 0, 2. So the y-intercept is pretty easy to find. You just plug in your x equals 0. Now what we need to do is go plug that into our calculator. All right, so this time I didn't have time to do it. So we have negative 12x squared. Remember, okay, it does that. And minus 2n, or 2x in this case, and then plus 2. Now I don't know what my scale is looking like, but it looks like that, and it's quadratic, so I think that's good. Now what we could do is we could move it up, because trying to see what's in here is going to be a little hard, I think. So I don't think I need to have quite that big. So maybe minus 10 and 10 and maybe a 2. Let's see what that does. All right, so that gives me something a little better to work with. I can squeeze it in on the edges too, I think maybe. And again, this is all just to make it so it's easier to see my actual points here, here, and here. All right, so what are we going to do? Well, we're going to do the same thing we did before. We're going to trace, and we're going to go 0. And so we have to be left or below the line here for the left bound. Up here, we go to the right. We choose a negative 1/2, 0. And if you remember, we had a negative 1/2, 0. So that looks good. Now, let's move over here because we know we're going to be over here. Now, let's do another trace. And we're going to do another 0. I guess we have to arrow over. So that's my left bound. Now my right bound's over here. And I get 0.33333, and that's going to be equal to 1/3, 0. So that looks good. And so now the only other thing is my y. And so what I'm going to do is I'm going to say enter. I'm going to say when x is equal to 0, because when x equals 0, that's going to be where it hits. And it says 0, 2 is where that hits. Okay. That's going to be, I think, the best way to do this, and so that's going to be another one. Now you could hit trace also apparently, and then hit 0, and that gives you the same thing. But I think it's just easier to hit the calc and hit the value, and then say 1, and then hit your 0 at that point. So that's the best way to do it. You know, the if we look over here, it said hit trace 0 enter, but if you just calculate, that's the same thing as that trace. Okay. All right, so I think we have all of the correct values here, so let's move on. Continuous function. Well, what's a continuous function? Well, that means it has no breaks in the graph, such as you can draw it from left to right without lifting your pen. So, you know, if we're thinking about some kind of function and it's going, you know, like this, and maybe it's getting bigger and it goes up that direction, and this one continues on down there. We never lifted our pen, and that's going to be a continuous function. Now, what is a smooth curve? Well, it's a graph that has no sharp corners. Well, if we consider that as a curve, this one has no sharp corners. The turning points are rounded corners. You know, we didn't have something like that would be not a sharp, not a smooth curve. That would be kind of pointy, and so that's not going to be what we need. We need something that just kind of rounds around, and that's going to be a smooth curve. Okay. Now, our intercepts and turning points of a polynomial. So a polynomial of degree n will have at most n x-intercepts and n minus 1 turning points. So if we think about this, so we're going up, that's going to be a turning point, that's going to be a turning point, that's going to be a turning point, and that's going to be a turning point. So we have 1, 2, 3, 4 turning points. So 4 plus 1. So the degree here is probably going to be some x to the 5th. Okay. And that's that at most. Okay. Again, that's at most. Now, where are those intercepts? Are that if this is that, so we have 1, 2, 3, 4, 5, and that's what it said. It's going to have at most 5 x-intercepts, and so that would be how we would see the at most. Now, it could have less. Maybe you came down here and went through those points as far as your curve goes, and so that would only have 1, 2, 3 uh, intercepts, but at most it will have is in. And so that's kind of what we can see drawing through there. Okay. All right, so our question below then says, determine the maximum number of x-intercepts and turning points without graphing. Well, how do we do that? Well, we have to find the degree of the polynomial. And again, the degree of the polynomial is going to be the one with the highest in value. And so we look here. As that's written, that's not in decreasing powers. So here we have a 0, here's a 9, here's a 4, here's a 12, here's a 3. So this is actually our leading term. Okay, so the leading term is 14x to the 12th. Okay, so what does that say? Well, n is equal to 12. So that means at most 12 intercepts. Okay. Now, and then it means also n minus 1, which is equal to 12 minus 1 equals 11 turning points. And this is, again, at most 12 intercepts and at most 11 turning points. Okay, so that's going to be how that works. Now, what about our next one? The next one, we have a 1, a 2, a 3, and a 0. So this looks to be our leading term. And so n is equal to 3, so we're going to have at most 3 x-intercepts, and we're going to have 2 turning points. Okay, because it's going to be 3 minus 1, which is going to be 2. Okay, that's going to be our at most values for this one. And again, we can't just look and say, hey, our first term is 108, so there's no intercepts and no turning points. You have to actually look, write it in decreasing powers, or keep track of the decreasing powers and say which one is which. Because if you look at this one directly and say, oh, hey, that's a 1, so that's going to be my leading term, then you're going to get it wrong. You have to look and find the one with the highest power. All right, so looking at this, from the graph, we're supposed to make generalizations about the equation. Is it odd or even, the number of turning points, and its coefficient? Okay, well, let's look at it. So we look at end behavior. End behavior is going to tell us basically if it's odd or even. And so if we look at the end behavior here, we have one here and one here. So what does that look like for end behavior? Well, doesn't that look like something like that? And what is this? That's odd degree. Now, what else do we know? The number of turning points. Well, we have 1, 2. So we have 2 turning points. And what is the coefficient? Well, the coefficient, k, is going to be less than 0 because it looks like this, okay? So that's kind of what we have. Now, what else do we know? It's 2 turning points, so odd degree, and probably with 3, because we have 1, 2, 3 x-intercepts, that's going to give us degree probably of 3 for n. Okay. And so that's kind of what we're guessing here. And so, that's going to be what we're going to get for this, for the most generalized term. Now, number 2 is over here. So here, what do we got? Well, that looks like just x squared, right? It's an even function. So even degree. Now, how many turning points? We have 1, 2, 3. So we have 3 turning points. And so that means we're going to have 4 is going to be our possible intercepts. But if we look, we only have 2. So what we have to say then is this one doesn't follow the thing. At most, how many could it have? At most, it could have 1, 2, 3, 4. But we've only got 2 intercepts for x. Okay. And so, because we have 3 turning points, 2 intercepts for x, we can have at most 4 x intercepts, which would give a degree of 4, which makes sense because we know it has to be even, and with n minus 1 being 3, that is probably going to be our degree of this polynomial. Okay. What about the next one? Well, this one, it goes down here, it goes up here, so it kind of looks like this, which means it's an odd degree. Okay. What else do we know? Oh, did we write down the coefficient here? Here, k is going to be greater than 0. Okay, so we know that coefficient. Now here, what do we know about k? Well, k again, it's going up like that, so k is greater than 0. It's odd degree. And how many turning points do we have? 1, 2, 3, 4. So we have 4 turning points. So n minus 1 is what that is equal to. So n is equal to, we have 5 is the degree that we're going to say. Now, does that match being odd? Yeah, it matches being odd. Now, how many x-intercepts? Well, there's just 1. Okay, so there's 1 x-intercept, but we have a possibility of 5 at most. So remember, at most, n is equal to 5 because of the number of turning points here. Okay, so that's how we can kind of go looking at a graph and seeing, the end behavior tells us the degree is odd or even, and then we see our number of turning points. That's going to be n minus 1, and so if we add 1 to it, that's going to be our n, and then this is going to help us lead us into actually writing what the function is as an actual function, as an equation. Okay, so that we're working our way towards that. All right, so let's pause there.